Good morning, good afternoon, good evening. My name is Ian Coates. Welcome to Math 1031 Asynchronous Summer 2026. I hope you guys are doing great. It is now week 5. Things are starting to heat up. Your assignment is due there this week. Let me know if there's any issues. As well, your quiz 1 will go out, and it's out. So make sure there that one is due there next week. Make sure to check the announcements of when everything is due. And if you have any questions at all, shoot me an email there, ian.coates@georgiancollege.ca. So the assignment is still ongoing. The quiz 1 is out. It's due there next week. And next week there's no new material. Okay, the assignment 1 was weeks 1 to 4. The quiz that's out now is weeks 1 to 5. And that culminates all the information there as far as test 1, which will be next week. I'll update you guys on that there sooner than later. But first, let's get through the week 5 material. And then at the end of this video there, we'll have a look there at the quiz there that's out now. And we'll just kind of go through it and show you guys. You guys can kind of see what's going on here. Okay, so we'll hit that one there at the end. So please don't go anywhere. Well, yeah, you're watching a video, go wherever you need to go, but pause, come back to the video there, and make sure to have a look at because at the end of it there, we're going to go over the quiz that's ongoing. All right, let's go here. So today, we are dealing with organizing and presenting quantitative data. You remember there last week there for week 4, we dealt with qualitative data, right? Remember noir, nominal, ordinal, interval, and ratio, right? Remember those guys? So this is where we are at. That is where we came from there last week. And section 2.2, as per the syllabus, this concludes all of the information, okay, for your test 1, week 6, okay? Your quiz 1 incorporates all the information there, and we'll talk more about your test and that kind of stuff there later on. Okay, let's go. So, organizing and presenting qualitative data, that's where we're at. Recall that quantitative data are numerical values, quantity, right? How many, how much, right? Are numerical values that represent a quantity or a measurement and are often accompanied by a unit. Example, dollar signs, centimeters, days, hours, minutes, these kinds of things, right? So it's also very important to recall the difference between the two subcategories of quantitative data. There is discrete and continuous, right? Discrete is made by counting. Continuous data is made by measuring. So if you're going to count the people in an elevator, right? The only numbers you're going to have are like 1, 2, 3, 4, 5. You're not going to have 3.25 of a person, right? It's only going to be whole numbers, 1, 2, 3, 4, 5. Whereas measuring, you can have 3.25 meters, 3.79 meters, right? So, yeah, just going through, that's a bit of review there because we're going to touch on that there again, okay? Discrete data, counting. Continuous data, measuring, okay? So, ungroup frequency distribution, organize the raw data into a table that shows the number of times each unique value occurs in the data set. Okay, we're gonna just kind of continue on where we left off there last week, but we're gonna take it into, and this is where you really want to let the numbers sing, right? I'm gonna hand you mashed potatoes, something like this right here. You're going to see something very familiar there in the quiz and test there next week, right? Doesn't make any sense, right? I've got a bunch of 1, 3, 2. I got 1s, 2s, and 3s all in mashed potatoes. And your job there is to organize this and let the numbers sing. What do the numbers have to say? And it's all about organizing the data. And we're going to tally chart, which we introduced there previously, frequency table there. So you have a look. The ages and years of 15 young dogs that were observed at a veterinary clinic last month were recorded as follow. So I have all these dogs there, there's lots of 1-year-old dogs, 2-year-old dogs, 3-year-old dogs. I don't see any 4-year-old dogs, so it's 1, 2s, and 3s only. Okay. Organize and present the above data using a tally chart and frequency table. All right, let's go. So you see there that what we've got, tally charts in green, frequency table there is in yellow. So there's your tally chart right here, right? So you're just taking all of the, there's your ages, 1, 2, 3, all of the ages that are 1, 1, 2, 3, 4, 5. So I should have 5, and I do have 5, and you'll see 1, 2, 3, 4 with a slash. Anything else is not acceptable when you're talking a tally chart. Groups of 5, right? And then your frequency, there is 5 numerically. So you draw the 3 columns, list the dog's ages in the increasing order, okay, tally marks, and then from the tally marks there, you get your frequency distribution right here, okay. Hopefully there that's okay. Let me know if it's not. Cumulative frequency. You know what I mean? We're still dealing with frequency here, right? You remember what frequency was, right? There was 5 out of how many here were 1-year-old, and 3 out of the total were 2-year-old, and 7 out of the total were 3-year-olds, right? That's your frequency. Well, cumulative frequency is the total frequency of all data values less than or equal to a particular value. Like that made any sense. I'll show you. Then there's something there called the cumulative relative frequency. Again, the definitions here aren't great, but once you see what they are, then I'll show you. Don't worry. The cumulative relative frequency is the cumulative frequency expressed as a proportion or percent of the total number of values in the data set. And basically, as you go along, you're just adding one to the next until you encompass all data. We'll show you. So, constructing relative, cumulative, and cumulative relative frequency distributions. Okay, yellow, green, and blue. All right. So, from that same set of data, nothing's changed, right? So, there's your age, right? We had a tally chart in here before, right? Remember, it was 1, 2, 3, 1, 2, 3. There's your tally and your frequency, 5, 3, 7. We should have the same numbers there. There's your age. Tally chart there would be in here, and there's your frequency, 537. Total is 15. Okay, good, very important. So now you'll see what the relative frequency means. Is you take 5 divided by the total, all right, times 100, right? There's your 100%, which so 5 divided by 15 would be 0.333, but multiplied by 100, it becomes 33.3%. So 5 out of 15 represents 33% of all the data. Okay? 3 out of 15 equals 20% of the data. 7 out of 15 is 46.7% of the data. And if you add these guys up, you will always get 100%. So in this, at the bottom here, totals for relative frequency, you should always get 100%. Okay? Now, cumulative frequency. You see, as we're moving along from 1 to 2 to 3, I'm going to show you here, right? So, have a look here. You'll see here that your frequency, and in this case here, your cumulative frequency are the same. That's because it's the first row. But we're going to start gathering everything from this row and adding it into this row. Okay? And I'll show you why there, and you'll see there that the cumulative frequency there for, okay, the 1s and the 2s, and you'll see there it's 5 plus 3. So you take these two numbers here and you add them together, and you get 8. That means, and why is this important? Because at a glance there, I can see there that, 33% of the data lies here, and 20% of the data lies here, and 46% of the data lies here. But maybe I want to ask myself, I'm interested in getting a dog less than 3 years old. Okay, how many dogs here came in that were less than 3? And you just look at this right here, 8 divided by 15, right? And look, that's what we get. Remember your relative frequency here? here you have the cumulative relative frequency. Okay, so it's going to add up to 100% here. So my cumulative frequency, 5, and then right here it's 5 plus 3, which is now 8. And if I want to include all 3, I'm going to incorporate all the data. So 5 plus 3 plus 7 equals 15. So you're just kind of gathering your stones into your bag so your bag gets heavier. And this number here should always equal the total. And as with the relative frequency here, we're talking about percentage. All right. So as we gather our stones, we have 5, and then 5 plus 3 is 8, and then 8 plus 7 is 15. That's all data, right? The cumulative relative frequency does the same thing, incorporates all data, but only as a percentage. So 5 represents 33%. Now it'll be 5 plus 3 is 8. 8 out of 15 represents 53%. Okay. And then now 8 plus 7 equals 15. 15 out of 15 obviously corresponds to 100%. So that should always equal 100. That number there should always equal the total. That number there is always 100% too. Okay. The sum of all the relative frequencies in the relative frequency distribution should always equal, should be 1 or 100. And why they say 1 or 100, you see they're multiplying by 100, but if you just didn't, 5 divided by 15, you get 0.333. You just get a decimal, a decimal, a decimal, add them up, you would get 1. Different schools of thought, doesn't really matter. Okay? So that is your age. Tally chart was on the previous. There's your frequency, relative frequency, right? Where you take the frequency divided by the total. Okay, multiply by 100, you get a percentage. Add them all up, you should get 100. Cumulative frequency, you're gathering those stones as you go. Okay, so this row here only has 1 row, but this row here incorporates 2 rows. This row here incorporates 3 rows. Okay, and same thing here with the relative frequency, you're just dealing with percentage. Okay, moving on. So dot plots are graphical representation of the frequency for each value in a quantitative data set using a series of vertically stacked dots on top of each data value. Yep, you're going to have to do this one there for your quiz. It's not too difficult. You see, we're using the same data here. Construct a dot plot for the age data of the 15 young dogs from the previous example. So you just organize them there. And there's your age. If you want, tally chart, frequency, right? There are 5 one-year-old dogs. So 1, 2, 3. 1, 2, 3, 4, 5. There are 3 2-year-old dogs and 7 3-year-old dogs, right? So basically what you're doing is, you don't know it yet, but you're actually creating kind of a histogram. You're creating a bar chart, right? Because now you can, and you see you're letting this mashed potatoes, this nonsense data, I'm looking at it, I can't see anything popping, right? But then once you organize it, now you can see, hey, visually, yeah, I can see there, quick and easy there, that the least represented age of dog is 2 years old. The most represented is, there's a lot of 3-year-old dogs. Okay, and you can kind of see what's going on here. Picture's worth 1,000 words, right? So you'll have to learn, you'll have to do that there for your assignment. They're not too bad. Okay. Stem and leaf plots are quite famous in that, again, they take the mashed potatoes and they can quickly give you an idea of what is happening. The stem and leaf plots are tables in which each data value is split into a stem and a leaf. Okay, the right-handed most digit of each value are the leaves, and the left-handed digits are the stem. So you'll see here, these are the numbers that we're going to use, right? So this is so you've got numbers in the 30s and numbers in the 40s, okay? And this is a stem of all the numbers in the 30s, and you'll see there, on the tree trunk there's the 30, and here are the ones: 33, 35, 38, and 39. In order to do these numbers here, I would need to make another stem where it would start with 40s and 42, 43, 47, 48, which is what we have here. Now, how do we easy peasy represent this? These are quite nice. Okay, let's have a look. This is a typical stem and leaf plot. Okay, and all it is just basically a little chart. Takes 2 seconds to create, right? And this is your stem, right, which corresponds there to the tree trunk. And then this is your branch. This is your leaves, right? So there's your same numbers. And there you go. There's your 33, 35, 38, 39, 33, 35, 38, 39, 42, 43, 47, 48, 42, 43, 47, 48. And what you're doing is you're organizing the data. And, you know, this goes from mashed potatoes. Well, it's really not because it's ordered. Somebody's ordered this, right? So you can kind of get an idea. And visually, you know, once something even as simple as ordering it, you can see there that I have 4 numbers in the 30s, 4 numbers in the 40s. But, you know, doing it like this as well, you see the same thing. So you'll see that the data there is basically 50% split between 30s and 40s. All range of 30s you have from 33 to 39. All ranges of 40 pretty much 42 to 48. Okay, so that's what's going on there. Yeah, and it's important there to organize the data, okay, in order. Okay, and I'm just looking here that all of the data has been, yeah, this data here was already ordered there to begin with. On a quiz or testing situation, I will most certainly not order it for you. You have to put it into order, okay, because the numbers have to go in order, right? 33 is lower than 35. 35 is lower than 38. It's got to be sequential. You can't have an 8 here and a 4 here. Okay, and that is represented here as well. Okay, good. So the data regarding the number of prescriptions filled in each of the 15 hours at a certain pharmacy was open. It's collected at the end of the day and summarized in the following stem and leaf plot. The number of prescriptions filled over a 15-hour period are, okay, so this is what we've got going on. Okay, these are the number, and you can see them all here. They're not ordered at all. I got 29, 30, 40, 41, 6. I got, oh yeah, sorry. There you go. That's what I was looking at. Good. Please make the adjustments there on your PowerPoint there. I was wondering what was going on. Why was the number was doubled? But you'll see here, there, that these guys, okay, these guys are ordered, okay, which kind of makes it kind of nice for you, okay. And what you do is, you look, you have 6, 7, 10, 11, 13. That's the very first thing you got to do. You got to put them into order, okay. And again, it's all about making the data sing. What are the numbers really saying to you? And this is a very quick and easy way of letting the data talk to you. So here I have on your stem and leaf plot, I have 6 and 7. These are single digit. Okay, this is single digit data. So therefore I would put a 0. Right? That indicates to me that there is a 6. Okay. And I don't know why that's a 7. Maybe that should be an 8. There you go. So you have 6 and 8. Okay. And then you have 10. Right? There's your 10. Okay, here's your 11, here's your 13, there's your 14, right? It's all right there. And then 26, 28, 29. Can you see the numbers there? They're kind of jumping out at you, right? They're just following along sequentially. 26, 28, 29. There's 30, 33, 38, 39. There's 30, 33, 38, 39. 41, 40. So all the numbers are represented there. And you can kind of see did I do it? Yeah, I did it on the next slide there. Just this, it takes a couple of minutes to do, and basically what you're doing is you're making a graph, right? I'll show you here in the next slide. You're making a graph, and it's telling you there that this is what we call bimodal, where there are 2 points of interest in this graph. And why is that important? Well, during these times here, okay, we sold a lot. And what's happening? How many prescriptions did we sell? Look here, we sold 41 and 44. Those are ridiculously, that's a lot of prescriptions there to sell. So, you know what I mean? You're analyzing, you're breaking it all down there. So in 1 hour, there were 6 prescriptions filled. In another hour, 8 prescriptions were filled. All right. In another hour, there was 28 prescriptions filled, and in other hours there were varying amounts as well. Okay, this is over a 15-hour period. And from a pharmacy point of view, it would be very interesting to know what hours did we sell the most prescriptions, because you might want to hire somebody else during that particular time to help facilitate, because if you're filling 41, 44 prescriptions in 1 hour, you probably need a little bit of help. And again, just based on this organized data, now you can answer questions, and that's what the quiz will ask of you. Next week's test, I will ask your opinion. Okay, I'm going to give you mashed potatoes. You're going to organize the data. You're going to do a graphical representation of it. You're going to organize it somehow in some fashion, whatever. And then I'm going to ask you your opinion. What do you think is going on? Right? What is the data saying? So in this case here, what is the total number of prescriptions filled over the course of the day? Well, you just add them all up, right? Here, 6 plus 8 is 14. 10 plus 11 plus 13 plus 14, 10 plus 11 plus 13 plus 14, add them all up, 370 prescriptions per day. Now, other hours were busier than others. In this particular hour, we only sold 6 prescriptions. In this particular hour, only 8. What hours were those, right? These hours here were very busy. You want to hire more counter staff there, okay? So 370 prescriptions filled over the day. Okay. What is the highest and lowest number of prescriptions filled in a given hour? 6, 44. You can easily see that. Okay. Calculate the number of high workload hours for the pharmacist. A high workload hour is defined as one in which 30 or more prescriptions are filled. So calculate the number of high workload hours. You're looking at all of them over 30. Right? How many hours? You had 1, 2, 3, 4, 5, 6 hours were high workload, right? During this hour, we sold 30. During this hour, we sold 33 prescriptions, 38, 39, 41, and 44. So 4 plus 2 is 6 hours. Okay? Just letting the data talk. That's all we're doing. All right? Group frequency distribution. Organize the raw data into groups called class intervals, or bins, or classes, and display in a table the number of data values in each interval. So we looked at the whole idea of a tally, and you look here, and this is a perfectly acceptable tally chart. Look, you have your number 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, and these are the number of occurrences. Well, you look at that, and if you tilt your head and look at this, you've got 1 here, 1 here, 1 here, 2, and 1. You know what I mean? It's pretty flat. It's pretty boring. I'm kind of losing interest. There's not enough, and this is good statistics, but it's not the best statistics. Okay? We use group distribution there in the following cases where the data is discrete. Remember, discrete, right? We can't count half a human, but is very spread out. You can kind of see that. The data is continuous. All right. And you see now, if we take the same data and organize it into here, can you see how this is a little bit better than that? And how so? Well, here I have, out of all this data, whatever we're talking about, bananas, number of peaches, batteries, whatever, it doesn't matter. Okay? All I know is that my range here is 1 to 8, and I only have 2 bananas on the lower end, and I have 4 bananas on the upper end. So at least that gives me the majority of my data is higher. At least it's telling me something, right? And yeah, I can see that from here, but it's not popping out. And that's what, the whole idea here is statistics. You go into a board meeting and you have all these graphs and pie charts and these kinds of things. That's what CEOs want to see. This whole behind the door trying to explain me what statistics is, they just want to see a nice, beautiful pie chart that says profits are going to go up 54% if we do this, right? And that's why this provides more detail than this, even though they represent the same thing. And this isn't necessarily incorrect, okay? So this is the reason why we sometimes use groups. And because this is discrete, right, we're not measuring, we're counting, right? So I'm not going to have 4.5 humans. Okay, I'm going to have 1, 2, 3, or 4. So I created one group of 1, 2, 3, 4, and then another group of exactly the same length. 5, 6, 7, 8. Okay, your groups have to be the same. All right, let's go. All right, so the whole idea here is that there is something called an LCL, what we call a lower class limit, right? Right, lower class limit, higher class limit, okay, upper class limit. So the lower number on the interval is called the lower class limit. The upper number on the interval is called the upper class limit. So just going back to our previous example here, 1 LCL, 4 UCL. The size of the interval is called the class width and is the difference between the LCL and or the UCL in any of the two subsequent classes. So, your class width there is, the whole idea here is 5 minus 1 is 4. And that makes sense, right? Because your class width is 1, 2, 3, and 4. There are 4 actual possibilities that could exist in here, right? When we do a tally for here, and with organizing the data, we can lose information. You see, I know that there is 1 tally for 1, and 2. This tally here is exactly because there's a number corresponding to 3. This number here means that that's a 5. But when we put into these bins here, right? Because we have these groups of 1, 2, 3, or 4, that tally mark there, I've lost a bit of information. And I don't know if that tally mark there, that first one that my arrow was pointing at, hopefully there you guys can see that, or if the second one, it doesn't really matter, is that a 1, 2, 3, or 4? I don't know. But all I know is that each of those tally marks right there, they correspond to a 1, a 2, a 3, or a 4. I don't know. Okay, so you do lose a little bit of information, but it's worth the risk, right? Here we're talking about group frequencies. So, constructing a frequency distribution for continuous data. Continuous, you remember, discrete is counted. Can't have half a human. But continuous is measured data. Okay? The triage nurse at an ER records the weight in kg of 24 patients seen during her shift as follows. So here, these are all kg, okay? 61.2 kg, 51.6 kg, blah, blah, blah. They're all here, continuous data. Okay, good. Again, mashed potatoes. Talk to me. What's the data saying? create a tally chart, frequency table. Okay? So, first thing, find your highs and lows. Right? There's this one here on the quiz. There's a little bit of work to do there. I save you a lot of work there on the quiz, but the whole idea there, I ask you to do this there on the quiz. So here you've got 51.6 and 123.2. That's your high and low values, your min and max. You will need to find those. Best to put these into order anyway. Okay. So determine the smallest value there for K, right? We're trying to find the number of classes. You generally want K to be between 5 and 20. Is that always the case? No, but on a testing situation, if I do ask you to do this there, you would want your K in around a minimum 5. But you'll see there, determine the smallest value for K for the number of classes so that 2 to the power K is greater than or equal to N. And N being the number of data points. That's these guys here. Okay. 2, 3, 4, 5, 6, 7, 8. I have 24. Right? So in this case here, now I need to figure out a value for K that is just one size bigger than 24. So 2 to the power 5. Okay, so 2 times 2 times 2 times 2 times 2 is 32. That's 1 up because 2 to the power 4 would be 16. That's too low. Okay, so 1 up from 1 power up from 24 gives us 32. So therefore K is 5, which means there that we are going to have 5 classes. Because we're going to group this data. Watch and see. So we just found out our highest and lowest value, right? 123, that was this value, and then 51.6 was our lowest, right? So there's my high and my low divided by your K value, which was 5. So therefore now we have a class width of 14.32. So that means there that, and just going back here, you remember these guys here? The class width in this particular case is going to be 14.32. In this one, the class width here was 4, as you'll remember. This new example, the class width will be 14.32, which we just round up to 15, obviously. Okay. Regardless of what number gets spit out here, you always jack it up 1. So regardless of whether the result was 14.5, in this case here we got 14.32, but let's say it was 14.5, 14.91, or even 14 bang on. Doesn't matter. You kick it up 1 to 15. Got it? Good. So you set your first LCL to the minimum value in the data set, okay, or a convenient number just below the minimum value. So in this case here, your lowest number is 51.6. Just take it down to 50 because it's a nice convenient number, and we'll show you. That's you just created your LCL, your lower control limit. Okay, establishing there the LCL by starting with the first. Okay, since the lowest class will start at 50, the class width is 15, as we already said, and there are 5 classes. Remember, that's equal to K. The LCLs of the class will therefore be 50, 65, 80, 95, and 110. It may or may not be making any sense to you right now, but just remember your lower class limits. Remember you have 5 classes. You'll see it all when we put it in a tabulated form. Okay? If the first LCL is 0 and the class width is 10, then the LCLs, the next would be 0, 10, and these are the lower class limits for each one. And we'll show you that there in 2 shakes of a lamb's tail. If the data is discrete, remember, can't count half a person, set the upper class limit of each class to be 1 value below the lower class limit of the subsequent class. Remember that, 0 to 9, if it's discrete, you can't have half a human, right? And that's what this one was right here, right? 1 to 4, You can't have 4.5 because we're counting people or bananas. So the next one, the UCL here would be 4. The LCL here would be 5. So that's what they're talking about right here, if I can find out where we were. Yes. So again, if the data is discrete, set the UCL of each class to one value below. Okay, so remember 0 to 9, and then the LCL for the next group would be one higher than that one, 10 to 19, 20 to 29, that kind of a thing. But if the data is continuous, if we're measuring and we can count 0.75 meters, then you have to use the less than sign. You have to use this guy here. All right, and we'll show you. If the data is continuous, you set the UCL to the same as the LCL of the next class. It's just you use this less than sign. Since the data is continuous, right, we are talking about this data here, the weight, okay, in kg of these patients. These are what the groups are going to look like, right? Remember, we had 50 to under 65. And then the next group will be 65 because 65 is not included. It's all numbers under 65. So 64.999999999, that is in this group. 65 and above is in this group all the way up to 79.9999999. And this group here has 80 to 94.999, 95 to 109.999, and 110 to 124.999. That's what we're talking about. Okay, so that's for continuous. If you're using discrete, you can have these bins, right? Because you don't need a 9.5 because we're counting humans, or bananas, we're counting things, right? But if it's measuring, you can have decimals, so that's why you need to have that less than sign. Okay? We'll show you what's going on there soon. So, same data, right? We using the highest and lowest, right? We found the K value. We found the class width, which in this case here was 14.32, so we kick it up there to 15. Come on, Harley, outside. Oh, beagles. Yeah. They're always, they're, make sure to get a lid for your garbage for sure. But anyway, you'll see there that the lowest value was 51.6, which is why we chose 50. Remember that? Okay. And then the class width was 14.32, which we kicked it up there to 15. So it's 50 to less than 65. 65 to less than 80, right? 15, 15, 15, and 15. And there's your tally chart. Easy to count. I got 5. I got 9 here. I got 5, 4, and 1. And then there's your frequency distribution. Okay? And even organizing it in a simple tally chart, you can kind of see a little graph. And you can see where the bulk of the data is. Because ultimately, that's what statistics is. It wants to know what people are thinking. It wants to know what the majority of people are thinking. And some statistics, you know what I mean, they're looking for, the outliers. What are they thinking? It's all based on that kind of stuff. And you can see right here, the majority of the data is in this range. So if you were selling Pepsi or something there to these people or whatever, I know we're dealing with weight in kg, but if this was a different study under different conditions, looking at different things, maybe selling shoes or soft drinks, you would be interested in this group right here. All right, let's keep going. The class boundaries are real numbered values that separate adjacent classes. For continuous data there, the class boundaries are basically the same as the class limits. So what we were dealing with in there was the class intervals there. You'll remember 0 to under 10, 10 to under 20, 20 to under 30. Basically, the class boundaries are just 10. Class boundaries would be the same, 0, 10, 20, 30, these kinds of things there. Okay. Um, Identifying the class boundaries there for discrete data. What are the class boundaries for the class interval? Okay. You've got, it's these guys in here, right? These are kind of the class boundaries. Okay. These are the intervals, right? But these are these boundaries, and you'll see the asterisk there in between. So the size of the gap is 1, so halfway is 0.5. The class boundaries are 0.5 on either side of the class limits. So in this case here, for this discrete data, right, can't count half a human, your class boundaries are negative 0.5, 9.5, you see how it falls in between, 19.5, 29.5, and 39.5. It falls in between these class intervals right here. Not a huge part of the course, but you'll see it again. Okay. The midpoint is kind of an interesting spot here, and we'll look at why when you get into ogives and these ones here. But the class midpoint, also known as the class mark, is the value at the middle of a class interval. Okay. It is calculated by adding the lower and upper class limits and dividing the result by 2. So what are the class midpoints for the class intervals? Here I've got continuous data 0 to under 10, 10 to under 20, 20 to under 30, right? And the midpoints there, you add 0 and 10 divided by 2, you get 5. Whew, that was tough. This one here, 10 plus 20 is 30, divided by 2, 15. And here I got 20 and 30, add those up is 50, divide by 2, 25. And you'll see there that it falls in between, right? 25 right in there, 15, 5, it falls in between, as it should, right? This is the midpoint. For discrete data, right, this is where you can't count half a human. You have 0 to 9, and then 10 to 19, and then 20 to 29, right? There are those gaps, right? 0 plus 9 divided by 2, 4.5. 10 plus 19, 29 divided by 2, 14.5. A little different, okay? Because there's a gap in there, it's not included, right? Because we're only dealing with bins. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only a limited amount of choices that can be chosen in here. So you lose a little bit of data. Okay. Moving on into histograms, you'll need to know this one there for the quiz and the test. These are bar charts with adjoining bars where the bar width represents the class width and the bar height represents the class frequency. Again, we'll deal with the same information there. Those 15 young dogs, years 1, 2, and 3, right? We did our tally chart. We did our frequency, as you recall, right? And now have a look at the histogram, okay, where frequency goes up the top. Okay, that's your y-axis, right? Your x-axis right here is always your information, your bins. And you'll notice there that they are touching. Histograms will touch. Okay? And you'll see there that, and probably the toughest part is trying to figure out the scale. You got to create your own scale. You got to create everything so it kind of representatively makes sense. Okay, so you see there, age 1 there are 5, age 1 there are 5, age 2 there are 3, age 3 there are 7. All right. So when the values are grouped, a histogram can be constructed directly from the frequency table. So let's group these now. Here we've got construct a histogram of the height of the dogs observed in a veterinary clinic. These are the height of dogs. This is a different, okay, we're not dealing with, yeah, that one there. We've got a new situation there with these pooches, all right? Let's have a look. So All right. Sorry, I'm just letting them go. So we're gonna take this data right here, and you have a look here. It seems to be ordered. Here I have 20 to 30. Here I have 31 to 37. Oh, here's to 40. And then I've got, 40 to 50. And then I have, numbers in the 50s right here. So why don't we just make 4 groups? And you have a look here. Because this is the height in centimeters, what is this, descriptive or continuous? Right? So this is the whole thing here. This is continuous data. Sorry, is this discrete or continuous? This is continuous. There's no gap in the data. So that's why we use this histogram here. And you'll see that the first group there, 20 to under 30, 30 to under 40, 40 to under 50, 50 to under 60. And then you just take these guys here, put them into their bins, and you get the frequency here, 6, 10, 8, and 4. So there's your frequency up on the y-axis. There's your information, your bins along the bottom. Please make sure that everything is fully labeled. You should have a title too. Everything. And if you're dealing with height, you need to tell me, is it meters or centimeters? So there are your bins there. First bin is 6. Next bin is 10. And you can see here now the data is singing. It's telling us what's going on. Okay? A distribution there is skewed to the right or positively skewed if its histogram has a longer tail. And you're going to see something like this. Generally speaking, statisticians love a histogram that looks like this. It's called unimodal. Okay, it's got one peak, symmetrical on both sides, and this is where we're going to deal with there towards the end of the course. Okay, unimodal, one peak. But sometimes there you can have unimodal, but then you have skewed, right? And you have a look here that's whatever we're dealing with here, the frequency, and there's a lot of low frequencies, okay, 1s and 2s. But then as we start getting into the higher, I don't know, whatever we're talking about, the number of pairs of socks people own, I don't know, whatever it is. But you'll see there that whatever we're counting here, as the number increases, this gets progressively and progressively smaller. That's what we call positively skewed. Inversely there, we can have a negatively skewed. Maybe we're talking about the number of oranges eaten in a particular town in 1988. Well, this town was obviously a bunch of freaks about oranges, and the majority of people there, unimodal, majority of people ate between 5 and 6 oranges a day. A lot of people ate 7 oranges wholly, and negatively skewed. There wasn't a lot of people there that didn't eat oranges. You see how that one goes. That's what we call negatively skewed. Okay, or skewed to the left. Skewed to the right, skewed to the left. Okay. You can have distributions. Obviously, this is the most ideal. Okay, but they come like this as well, and that's good information. It's telling you the numbers are singing. You look at this one. This is a distribution there that is, you're looking at it going, it's just a block, right? Sometimes called rectangular, in this case here called uniform distribution, where the entire population is thinking the same. Well, that's exactly what's happening here, right? You remember one of the goals there of stats is to try and find out what people are thinking. And the majority of people are thinking in and around 3s and 4s, right? But there's a good amount of people that are thinking 5s, exactly the same amount of people thinking 2s and 3s, right? A little bit of people thinking 6s, and that's what we want. But you look at this situation, you're going, what? Everyone's thinking the same? Everyone's thinking 5? Well, what if you had sent a questionnaire or interviewed people in an all-male adult jail? Or what if, a youth center there for troubled youths? Well, the majority of use, are teenagers. If you're in a male jail or female jail, or I don't know, whatever, if you were in everyone is pretty much the same age, between the ages of 18 and 34, generally speaking. And, so if your population that you're interviewing or asking the questions has constraints on it, that most certainly will affect your data. Okay? Let's go. Frequency polygon. So there's your histogram. And to make a frequency polygon, all line graphs that display the frequency distribution of the data set with frequencies plotted against the class midpoints. So you'll notice there, this frequency polygon starts on the line and then jets up to the first midpoint, to the next, to the next, to the next, and back down to the line. Okay? That's what we call a frequency polygon, and it just gives you another idea of what the graph looks like. So basically you have two graphs on one, whichever way you want to look at it. This is a nice visual which tends to back up what the histogram is saying. Okay? Outliers, as we were saying there before, if you were in the business of selling Coca-Cola or shoes, or that is where you would be interested in. These are the most people that are buying your shoes, or I don't know, maybe this is the most famous shoe size, which is size 10, and then you have people here that have size 11, size 12, and then there's Shaquille O'Neal all the way out here, right? But this is what we call a positively skewed, right skewed graph here, and you'll see that outliers, they do exist. They have a message too. Yes, statistics is interested in what the majority of people are thinking, but some businesses aren't interested in selling to the majority. Some businesses are only interested in specialized products. Size 17 shoes, extra large individuals, which make up a small percentage of the population, but if they can corner that market, they'll still make it big. Okay, and I don't know what we're talking about here. It's kind of irrelevant, but these outliers here, they exist on the fringe, and they have a story to tell as well. Ogives are line graphs or curves representing, remember that cumulative frequency, right? You row 1, you gather that stone, take it to row 2, gather those 2 stones, go to row 3, gather, you know what I mean? That's that cumulative frequency. And it's a really neat graph that shows you in a split second where the majority of the data is. So you have a look here at this one. Here I've got these class intervals here, 30 to under 40, 40 to under 50, 50 to under 60, and so on and so forth, right? And you'll see there that there is 2 individuals in this group, 4 here, 8, 11, 8, 5, 2, with a total of 40. Okay? What the cumulative frequency, and that's what you're going to use there for an ogive. You're going to use this cumulative frequency. And you remember 2 plus 4 equals 6. All right? 6 plus 8 equals 14. 14 plus 11 is 25. You see how you're gathering one stone, another stone, and all the way, and eventually this number here must match your total, right? Because you're gathering all of the stones, okay, as you go along, right? 14 plus 11 is 25, 25 plus 8 is 33, 33 plus 5 is 38, 38 plus 2 is 40. So this is what you're going to use there for your ogive, okay? There's your cumulative frequency there that we just looked at. Cumulative relative frequency, right? 2 divided by 40 is 5%, right? 2 divided by 40 is 0.05 times 100 gives you 5%, right? And then 6 divided by 40, okay, is 10%. Oh, sorry. 4 divided by 40 there is 10%. 10 plus 5 is 15. Remember, you're adding these guys up as you go. And just as much as that number here is 100% and will equal that number. When you're dealing with percentages, that number there should be 100%. 100% equates to 40, which equates to all the data. Okay. Now, and this is how you do an ogive. And I'll just kind of zoom in here a bit. There's your cumulative frequency. And, you know what I mean, we had from 5 to 40. You can't have any more than that, right, for this particular graph. So you're going to have all the way up to 40. And then you'll see here, relative cumulative frequency, there's your percentage. Now, these numbers are going to, you know, relate, right? 40, as you recall, is equal to 100%, right? So they should be on the same line, right? And your percentages should be exactly where 30 divided by 40 is 0.75 times 100 equals 75. Half of 40 is 20, 50, right? And you see what we're doing here? We're just going back. Remember these guys: 5, 15, 35, 62 and a half, 82 and a half, 95, 100. You see how that we're gathering one stone and adding it there to the next? Well, that you're just going to take that and you're just going to add those up. Okay? All right? And your 5, 15, and it goes all the way up until, and that's how an ogive curve looks. It's low in the top left, but you remember you're gathering one stone, so you're adding this data to this data, and then you're adding these two data sets to this one, and then to this one, you see it, and then eventually it incorporates all the data. Okay. Yeah, you'll have to know that one there for your quiz as well. Even a little bit of this, a time series data is collected successfully over a period of time. Please take note of this example specifically there, because you'll see something similar there in your quiz. A patient's blood pressure is monitored and recorded daily for 8 days as follows. There's your systolic pressure, there's your diastolic pressure there over the 8-day period, right? So for this particular day, this person had a BP of 164 over 98. Day 2, they had a BP of 156 over 94. Draw a multiple line graph to visually represent the systolic and diastolic blood pressure values recorded over the 8-day period. So how do we do this here? This is what you're looking for, right? Just kind of move on out here a little bit. See there's your, and it's got to be fully labeled for full marks, right? You got a title. Make sure there's a title. I think on some of the questions there, I put the title there for you, okay? But you'll have your blood pressure, millimeters of mercury with your units, right? mmHg, an appropriate scale. Please have an appropriate scale. You have to come up with that. You know what I mean? It wouldn't make any sense to have 600, 800, you know, 1,000, 1,200. It wouldn't make sense, right? You've got to make a good scale because you want your graph to be in the center of the paper. Okay? So there's your title, a good scale. Okay? On the bottom there, you know, we have our days, right? This was over 8 days, so you should have 8 days. And look, you have a dot for each one. Now, what's going on here? Systolic is blue, diastolic is orange, right? So you're going to take this data and separate it from this data. Color code it, okay? And just plot those points there. You've got 164 and 156. 164, 156, approximate, you know, I mean, we're not rocket scientists here yet. So, you know, just, you know, so it looks good. And there's your diastolic down here. And it's just interesting there. Again, you're organizing the data and letting it sing. And what is happening here over the 8-day period? Well, generally, it looks like there's a trend. And that's another thing that statistics likes. Trends. Predicting what's going to happen tomorrow, right? If we could only know the future, we'd all be bazillionaires, right? And you can kind of see here what's going on. There's an overall trend, systolically and diastolically, that the blood pressure is dropping. This individual is getting healthier. Just looking at a graph, right? And again, just to finish it off here, the whole idea, please make sure to color code at least label with a legend. The points correspond. You should be able to visually see the points, straight lines. Yeah, it's a nice one. So that concludes this week's information, but don't go anywhere. We're going to talk about the quiz that is out right now. Okay? So, as with the previous assignment there, hopefully there it's not too confusing. I've tried to kind of highlight what you've got to do. And everything will be highlighted in yellow. So use the following frequency distribution taken from data obtained in the number of minutes spent in ER room before seeing a doctor. And you'll see there what's highlighted is what you'll need to do. Fill in the following table. Everything is yellow. There you should be. There's your relative frequency. There are your bins. It's already done. There's your groups, right? Everything's done for you. This particular question, I want you to tell me the relative frequency for these particular numbers. I didn't give you totals here, but you guys will be able to use all that information there, figure it all out. Cumulative frequency and relative cumulative frequency. Here, the ages of 15 young cats were observed at a veterinary clinic. Boy, where did I get that question from, eh? Change the numbers around. So here's your ages, 1, 2, 3, 4. Right? This is discrete, right? We don't have 2.5-year-old cats. So I want you there to figure out your frequency. There's your totals, relative frequency, cumulative frequency, and relative cumulative frequency. Okay? And you'll see the marks are there. That one there is 4 marks. This one here is 5 marks. Construct a dot plot from the above data here on the below line. Remember that dot plot there? You're going to have those dots. Label it as best you can for a full 3 marks. Okay. Again, highlighted in yellow. Answer the following questions. So here I've given you a stem and leaf plot. Okay. And I want you there to answer the questions. And for this quiz here, there's no answer sheet. So what you're going to do, right, is you're going to do all the work here, do all the work here, here, and here. And then you're going to take great pictures so I can clearly see everything. And you're going to either you'll scan the whole thing in one. So there's one attachment, which would be very nice, page 1, 2, 3, 4. Or you'll label this one as P1, P2, P3, and P4. Okay, it just helps me mark because I've got a lot of these there. And yeah, the happier I am, the better the mark. Anyway, that's what's going on there for the stem and leaf. Here I've got line graph interpret. Apologies there, the quality didn't come out, but you guys can see what's going on here. We've got patient weight and cholesterol changes over 1 year. There's your 300, 275. There's a decent graph along the side. There's your months, and you can see what's going on. Weight in pounds is in red. Cholesterol is green. Okay, milligram there per deciliter. And answer the questions. Okay, and you can see them right here. What is the trend? Increasing, decreasing. Just asking you to circle. Okay, asking you there for the percentages there. That's what you're looking for there. So that one there is worth 4 marks. Okay, right there. Then this is a huge question right in here. This one here is worth 20 marks. And you'll see there that this involves question 13 to 19. Okay, so question 13, 14, 15, 16, 17, 18, 19. So that's 20 marks right there. And what's going on? Here I've given you mashed potatoes. This is the weight in pounds of 23rd grade boys at an elementary school. Okay, these are their weights. Okay, in pounds. Circle if the data is qualitative, quantitative discrete, or quantitative continuous. I'll let you guys go for that. Then I'm asking you there to create some weight classes here. Keep it easy peasy, don't go too much. I've given you the LCL, okay, of 40. Okay, and you fill in the rest. And again, keep it easy. All right, you can kind of figure it out here. If you look at the numbers there, this should be easier than it's looking. Okay, and I'm looking for frequency, relative frequency, cumulative frequency, and relative cumulative frequency. With that same data, I want you to create a histogram. Remember that histogram, right? And from that, and fully labeled, I've given you the title, all right, but fully labeled units, what are we dealing with here? There's your histogram, and then I want you to do a frequency polygon. Remember that line hits the center points, right? Okay. Then I want you to create a cumulative frequency, an ogive. You remember that one there? It went up and up and up. That's what we're looking for there. Give me details. I think most of them are here. There's your title, just looking for the line itself. That's why it's only worth 2 marks. Okay. And this one up here was worth 5 plus 7, so the histogram is 5, and the frequency polygon is 2. Okay. And from this information there's 3 little questions there I want you guys to fill in. Estimate the following based on your above information. Okay. So that's total 20 marks just for that question. That's half the test. Right there is that one question. Okay. I want you to construct a stem and leaf plot based on this information here. There's your stem, there's your leaf. Okay, 5 marks. And you'll notice there that I'm not asking you there for your opinion. Test 1, you'll be doing the exact same things all over again. Did I just say that? You'll be doing the exact same thing, but I'll be asking you there for your opinions. You'll be able to describe the trends, if any. But of course there will be. A patient's blood pressure is monitored and recorded daily for 8 days as follows. Oh my gosh, this question looks kind of very similar. Just different data. There's this patient's diastolic pressure over 8 days. Systolic. Here's the diastolic pressure over 8 days. Draw a multi-line graph to visually represent. There's your graph, blood pressure. There, a patient on medication. There's your BP, day 1. Draw your lines. Away you go. Okay, so fair amount of work, but I don't think it's that taxing. For goodness sakes, if you're having any issues at all, again, reach out to me, ian.coates@georgiancollege.ca. We have time. It's only week 5, but we're 2 weeks away from the tipping point. Okay? Even then, reach out to me. We'll get things done. Okay, guys, I hope that helps. That is due next Wednesday, June 10th. 11:59. I would like to have all those in, so please take note of that day. I know that the assignment there is due there on Thursday. I like to have Thursdays kind of the day to release things. I'm going to have the quiz due on the 10th, 11:59. Why? Because next Thursday I'm going to release your test 1. And I'll give you at least the weekend to do that. Probably have it due on Monday. So there's going to be some weird times here, but don't worry, I'm with you. If you have any questions, let me know. So this quiz right here is due Wednesday, June 10th, 11:59. Hand in 4 pages, label them appropriately there as those guys, and we'll get it all done. Let me know if you guys have any questions. Take care, be well, and we'll see you guys soon. Thank you.